Hi guys, welcome back to Octet Sci Academy. Today we're going to be looking at another interesting scientific concept. Last time we discussed the concept of matter, the properties, the various forms in which matter exists around us, and physical changes, chemical changes that matter is able to undergo. But you might begin to wonder, what then makes up matter? We've got the answer for you. That's what we're going to be looking at today. Today, we're going to be looking at the concept of atoms. Welcome, and let's get right into it. Atoms are what make up matter. It is when atoms combine with atoms of the same element combine with one another or with atoms of other elements in a chemical reaction. That is when we have matter in the various forms that we have it around us. For exam purpose, candidates can be asked to define atom or to state the difference between an atom and a mixture, or an atom and a compound, or an atom and an element in exams like WAEC, JAMB, GCSE, and so on. So this is how to define an atom for exam purpose. An atom is the fundamental unit of matter, like I stated earlier, and it is the smallest particle of an element that can take part in a chemical reaction. So an atom is a fundamental unit of matter, and it is the smallest particle of an element that can take part in a chemical reaction. And atoms retain the properties of the elements they're made of when they undergo chemical reactions. So matter or things around us are formed when atoms of the same element react with one another in a chemical reaction or combine with atoms of other elements to form new materials. Now we know that atoms is what makes up matter as we know it, either by atoms of the same element combining with one another, like you have in oxygen, or atoms of different elements combining together in a chemical reaction, like you have atoms of hydrogen and oxygen combining together to form water. But then, atom also has subparticles. That is, there are some subatomic particles that in turn make up atom. And let's look at those subatomic particles. Atoms have three subatomic particles. There is neutron, which is neutral. There are protons, which are positively charged, and there are electrons, which are negatively charged. This is another concept that can be assessed in certificate exams like WAEC or JAMB and the likes, that what they can ask for the correct charge of each of these subatomic particles. So neutrons are neutral, protons are positively charged, and electrons are negatively charged, as represented here. Now, where do these subatomic particles, where do they reside in an atom? Because these subatomic particles have their own position in an atom. So now we know the three subatomic particles that is present in every atom: proton, electron, and neutron. Protons are positively charged, electrons are negatively charged, and neutrons are neutral. They have no charge. But where do these subatomic particles reside? Where do they live in an atom? So neutron, which is neutral, is resident at the nucleus of the atom. The nucleus is the center of the atom here. So the nucleus is at the center of the atom, and this is where the neutron, that is represented by this blue ball, you can see there is no charge on them, so it's neutral, as well as protons that are positively charged. That is where they both reside, and that is where most of the mass of the atom is actually resident. It is at the nucleus where every atom has most of its mass, and the nucleus accommodates both the protons and the neutrons. And because of that, the nucleus is going to be net positively charged, because nucleus has protons and neutrons, that is neutral. So the overall charge of the nucleus is going to be positive because of the presence of protons that are positively charged and neutrons that are neutral. Which other areas do we have in an atom? We have the electron cloud, and the electron cloud refers to all areas that are around the nucleus. That is what refers to as the electron cloud. And then we have what we often refer to as atomic orbitals, which for O-level purposes is usually referred to as shells around the nucleus. If that is what you know, it is fine, which is often referred to as shells. And this is where you have a high probability of finding an electron, because electrons are always moving. So it's very difficult. They do not stay in one position. However, you're most likely there is a high probability of finding an electron in in an atomic orbital or an electron shell, if that is what you know. Now, what happens when atoms of the same element combine chemically together, or atoms of a particular element combine with atoms of other elements? What results when such happens? When that occurs, we now form molecules. So a molecule is when two or more atoms chemically combine together. Again, this is something that is usually asked in a lot of certificate exams. So you can be asked to define a molecule. A molecule is formed when two or more atoms are chemically bound together. They are the basic building blocks of many things around us. Now let's make our own molecule. This is an oxygen atom. To make an oxygen molecule in O2, like the gas we breathe in, I need to connect two oxygen atoms together using this chemical bond representation that I have here. So this is a representation of the chemical bond that is holding the two atoms of oxygen together. So let's go in and make our own oxygen molecule. So what we have here is an oxygen molecule made up of two oxygen atoms. One oxygen atom here, another one joined by a chemical bond. And then we have oxygen molecule. There are other examples of molecules as well. Another popular example is let's say carbon dioxide. That is the gas that is given off when we breathe out. We breathe in oxygen and we breathe out carbon dioxide, right? So that is one carbon and two oxygen atoms. So this is my carbon, right? One carbon atom, and then I'm going to combine two oxygen atoms to that to make my CO2. Here is CO2, carbon dioxide, which is the gas we breathe out. So this is a molecule of CO2 made up of what? One carbon atom and two oxygen atoms. Again, there are so many other molecules that we can make example of. Let's do one more. For example, another example is methane. So methane is CH4. That is, it has one carbon and four hydrogen atoms. So this is my carbon atom at the center, and I've attached four different bonds to it to represent the four bonds that are joining the hydrogen molecule, that are joining the hydrogen atoms to the carbon in methane. Go and go. And there we have it. That is our methane molecule, comprising of one carbon atom at the center and four hydrogen atoms. So there are so numerous examples like that, like we have here, like water, like ozone, oxygen molecule that we saw earlier, carbon monoxide, and carbon dioxide. Oftentimes, certificate exams like WAEC again, GCSE, often ask the differences between atoms and molecules. So we have a nice table here to show the differences between atoms and molecules. Atoms are the smallest. So now that we've made some molecules from various atoms to make things that we already interact with every day, like making oxygen molecule from two atoms of oxygen and making a methane molecule from one atom of carbon and three atoms of hydrogen. What are the differences between atoms and molecules. Usually, atoms are regarded as the smallest unit of matter. So, as it is, that will be the smallest bit that makes up matter. The atoms that now combine together to form different materials. Whereas for molecule, a molecule will be comprised of two or more atoms that are chemically bound together. Example, oxygen molecule has two oxygen atoms that are joined together by what? A chemical bond. Whereas for an atom, it exists on its own and it is fine. An atom cannot be further divided into smaller units chemically, although that might not necessarily hold 100% in all circumstances, but um, it is not something that you can further chop down chemically to make into smaller units. However, with a molecule can be broken down into the various atoms that make it up. So if I separate these two out now, I no longer have oxygen molecule, rather have individual oxygen atoms. Atoms rarely exist freely in nature because they're always looking to combine with one another and with atoms of other elements, except for elements that are unreactive. More often than not, you find atoms combined with other atoms. They rarely exist freely in nature. Molecule is able to exist freely in nature, like carbon dioxide, for example. It can exist on its own without combining with any other material. But atoms are always looking to combine with atoms of the same element or with atoms of other elements. So again, for example, like the oxygen atom that I showed you earlier on, they are happy they are individual atoms that when combined together will give us the molecule of oxygen, and you rarely find one single oxygen atom just lying around. It is very, very reactive compared to molecules where you have like carbon dioxide again, that is way more stable and less reactive. Now, let's make your own atom at home. So what do you need to make your own atom? Now that we've learned about atoms and molecules, the differences between the two and the relationship between the two, it's time for us to make some atom. We learned about the structure of atom and the components and the different areas. Now let's make some with materials that we already have. So for this fun experiment, you're going to be needing some paper, whether plain paper or things that are cardboard like this. That's fine. I'm going to be using both. Some cotton wool, scissors for cutting the paper, obviously, sellotape or glue. Sellotape is what I have. That is what I'm going to be using. You can use glue if that's what you prefer. I'm going to be using a bowl to make the circle on the on the various pieces of paper that we have here. So let's get right into it. So, guys, we've come to the end of today's activity where we have learned to make our own atom using paper, marker, and cotton wool, sellotape, and glue using the materials we have lying at home already. Don't forget to like, follow, share, and subscribe for more. If you want us to design any hands-on activity for any particular topic or concept, leave that in the comment section. I will take it from there. Don't forget to like, follow, and share with your friends and your colleagues. Thank you and see you next time. Bye.